You know, we're surrounded by this hidden world, a world of impossibly small, super high precision parts. Most of the time, you don't even see them. But here's the thing, these tiny little components are what make our modern lives even possible. We're talking about everything from the screws that can literally hold your bones together to the parts that make your car run. So today, we're going to dive right into the art of making the impossibly small.
So the big question is, how is it even done? I mean, how do you make something that's both incredibly tiny and potentially life-saving with just perfect precision? It sounds like it should be impossible, right? But it happens every single day. And we're going to break down exactly how.
And listen, this isn't some abstract, far-off concept. We're talking about real-world stuff. Think about it, the bone screws that help heal a nasty fracture, the hip implants that give people their mobility back, even the fuel injectors that make your car's engine way more efficient, or the critical bushings that, keep airplanes flying safely. These aren't just little pieces of metal. They are absolute pillars of modern technology.
Okay, so how is all this even possible? Well, the answer lies in this really clever manufacturing process. It's called Swiss-type turning. And it's an absolutely ingenious method designed specifically for making these kinds of small, super complex parts.
So what is it exactly? All right, picture a traditional lathe, where a big chunk of material spins around and a cutting tool moves in to shape it. Got it? Okay, Swiss-type turning basically flips that whole idea on its head. Instead of the tool moving, the material itself moves. It slides through a tight guide, right past a stationary cutting tool. It might sound like a pretty small change, but trust me, it has massive game-changing implications for precision.
Let's break that down. It's actually pretty straightforward. Just 3 steps. First, you've got the machine feeding the rotating material forward. Simple enough. Second, and this right here is the brilliant part, the secret sauce. A guide bushing provides super rigid support right up to the exact point where the cut is happening. Then finally, the stationary tool just shaves off material with incredible accuracy as it comes out. That constant, super close support, that's the whole secret to its amazing precision.
Okay, so we know what it is in theory, but, making it work perfectly in practice means you have to overcome some pretty fundamental challenges. It's not as simple as just turning on the machine. So let's look at the core principles that engineers absolutely have to master when they're working at this kind of microscopic scale. All right, challenge number 1. The absolute biggest enemy when you're trying to machine a long, skinny part is something called deflection. Just imagine trying to write with a really, really long, flimsy pencil. The second you press down, the tip is going to bend, right? Well, the exact same thing happens to metal. And even a microscopic bend during the cutting process can completely, totally ruin the part's precision.
And this is exactly where the genius of Swiss-type turning really shines. Remember that guide bushing we talked about? Because it supports the material literally right next to the tool, there's almost zero unsupported length that can bend. It's got nowhere to go. You combine that with incredibly sharp cutting tools and really fine-tuned cutting forces, and what you get is a perfect 3-pronged attack that just completely defeats deflection.
Okay, on to the second big challenge. Now this one sounds pretty simple, but it's just as critical. You got to get rid of the tiny metal shavings, what machinists call chips. See, in such a tiny, cramped space, if those little chips start to build up, they can scratch the surface of your perfect part, or worse, they can jam up and break the cutting tool. It is, no joke, a recipe for disaster. So how do you solve that? Well, this is where the machinists really become masters of control. First, they very carefully manage the depth of each cut to make sure the chips they create are small and manageable. They also constantly adjust cutting speeds and feed rates. And then, and this is cool, they use a constant flow of high-pressure coolant. Think of it like a tiny, powerful fire hose that just blasts those chips away and keeps the whole cutting path perfectly clear. All right, so we've gone deep into the fascinating how of it all. Let's zoom back out for a second and talk about the why. Why does mastering this technology matter so much? This is where we really start to see the huge, broad impact that this kind of next-generation manufacturing has on all of our lives. And the impact is, well, it's massive. Just look at this. A whopping 35% of these parts go into the medical field. Think about that. Then another 50%, half, is split right down the middle between aerospace and defense and the automotive industry. So yeah, these are not niche applications. We're talking about a technology that is a foundational pillar for some of our most critical industries. And here's where it all comes together. Let's connect those technical benefits to the real world.
That high precision we talked about, that translates directly into life-saving medical implants. Tight tolerances, that means more efficient engines and better performing systems. Superior surface finish, well, that just means the components have a much longer lifespan. And the enhanced efficiency of the whole process, that makes the production cost-effective. You see, every single technical detail has a real, tangible impact.
You know, one source really put it perfectly, and I think this just sums it all up. They said, Swiss-type turning is the perfect solution when you require precision, tight tolerances, and a superior surface finish. It really is the art of the possible, made real at a scale that just feels impossible.
And that really leaves us with one final, pretty provocative thought. We've just seen how this technology has already completely transformed entire industries. So the question is, as our ability to manufacture things gets even smaller and even more precise, what new frontiers are we going to unlock next? What technologies that seem impossible today will become tomorrow's everyday reality?